So this is question 2D from 2010 paper. You can pause the video to read the question. So when the electrons hit a sample, they may excite the atoms they hit and cause X-ray photons to be emitted. This part is tightly related with the model of the atoms, and the process of this is the electrons, right? The electrons hit a sample. They have kinetic energy, right? And they hit some sample. Now this sample has this sample is also an atom, right? So it has its own maybe the nucleus, and of course if it's got its own nucleus. Now let's use another color. And it also has its own electrons here, and then when this electrons hit these electrons, actually hit these atoms, they will cause this red electrons to be excited. And when they get excited, they jump up to the higher level, and then when they fall back, they will emit some of the photons. And this photon is here, what we have, X-ray photons. Okay, so we want to calculate the minimum voltage needed in the electrogon. So this is these blue electrons are emitted from this electrogon. Okay, they will shoot these electrons to hit this atoms here with sufficient energy. We want this blue electrons to have sufficient energy to cause the emission of X-rays from oxygen atoms. Okay, now X-ray has a wavelength of 2.36 times 10 to the power of -9 meters. So we can calculate the minimum voltage, right? We want to calculate here. So this is going to be V. V is going to be E over E. Now this E is it's charge, right? So it is a constant value. So if we want to know the minimum voltage, then we want to know the minimum energy here. And now energy is going to be equal to, the minimum energy is going to be equal to HF. Now we are given the lambda of this light, right? Lambda is going to be C over F. So we have E is going to be equal to should be F is going to be equal to C over lambda. So we have H times C over lambda, and this E is also EV, right? EV. So we also have this energy E is going to be EV. So we connect this 1 and this 2, so we can have HC over lambda is going to be equal to EV, and then your V is going to be HC over lambda times E. Now we have H as a constant, C as a constant, E as a constant, and the lambda is given. So we want to write it like this. Times 3 times 10 to the power 8. And lambda is given here, 2.36 times 10 to the power of -9 times E, 1.6 times 10 to the power of -19. It is going to be equal to, well, let's use our calculator, 6.63 times 10 to the power of -34 times 3 times 10 to the power of 8 over 2.36 2.36 times 10 to the power of negative 9 times 1.6 times 10 to the power of negative 19. So we've got 527 volts. It's going to be 527 volts. Okay, so state any assumptions you make. The assumptions we are making here is that the electrons from the gun should have enough kinetic energy to transfer. Actually, we use transfer to the sample atoms. So the electrons are excited and then fall back to emit enough energy to emit X-ray photons. Now, actually, this sample atom is your oxygen atoms. So maybe I should write oxygen atoms here. Oxygen.